How do weather forecasts actually work? Every time you check your phone to see if it will rain tomorrow or if the temperature will drop next week, you are tapping into one of the most complex scientific systems humans have ever built. Weather forecasting is not guesswork, superstition, or simple pattern matching. It is a powerful blend of physics, mathematics, technology, and massive computing power working together to predict how Earth's atmosphere will behave. The process begins with observation. All around the planet, millions of instruments constantly measure the atmosphere. Weather stations record temperature, humidity, air pressure, wind speed, and wind direction at ground level. Weather balloons are launched daily, rising high into the sky to collect data from different layers of the atmosphere. Over the oceans, ships and floating buoys send back vital information, filling gaps where land stations cannot reach. Above all of this, satellites orbit Earth, capturing images of clouds, storms, water vapor, and heat patterns, providing a global view that no ground system alone could ever offer. Once this enormous amount of data is collected, it is transmitted to forecasting centers around the world. But raw data alone cannot predict the future. The atmosphere follows physical laws, especially those governing motion, energy, and fluids. To turn observations into forecasts, scientists use numerical weather prediction models. These models divide the atmosphere into millions of three-dimensional grid boxes. Inside each box, equations describe how temperature, pressure, moisture, and wind interact and change over time. Supercomputers then solve these equations again and again, stepping forward minute by minute into the future. Because the atmosphere is chaotic, even tiny differences in starting data can lead to different outcomes. This is why forecasters run multiple versions of the same model called ensembles, each with slightly altered starting conditions. By comparing these results, meteorologists can estimate how confident a forecast is and identify the most likely scenario. Radar plays a crucial role, especially for short-term forecasts. Doppler radar sends out pulses of radio waves that bounce off raindrops, snowflakes, or hailstones and return to the radar dish. By analyzing these signals, meteorologists can see where precipitation is falling, how intense it is, and even how fast storms are moving. This allows for highly accurate short-range predictions, such as when a thunderstorm will reach your city, or whether a storm could produce dangerous winds or tornadoes. For longer forecasts, satellites become even more important. They track large-scale patterns like jet streams, tropical systems, and cloud movements across entire continents and oceans. Despite all this technology, weather forecasts are never perfect. The atmosphere is a complex dynamic system where countless variables interact at once. Small measurement errors, gaps in data, or limits in computing power can affect accuracy, especially several days into the future. This is why forecasts become less reliable the farther out they go. A one-day forecast is usually very accurate, a 3-day forecast is still quite reliable, but a 10-day forecast is more about identifying general trends than exact conditions. Human expertise remains essential. Meteorologists interpret model results, compare different data sources, and apply experience to refine predictions, especially during extreme weather events. In the end, weather forecasting is a remarkable example of science serving everyday life. It helps farmers plan crops, pilots fly safely, governments prepare for disasters, and ordinary people decide what to wear each morning. Each forecast represents billions of calculations, countless measurements, and decades of scientific progress working behind the scenes. The next time you see a rain icon or a sunny symbol on your screen, remember that it is the result of a global effort to understand and predict the ever-changing atmosphere that surrounds our planet. If you enjoyed learning how weather forecasts actually work and want more clear science-based explanations of the world around you, don't forget to like, share, and subscribe for more fascinating content.